Welcome, Dr. Sarat, sir. Sir?
Good evening, madam. I am
Good
here.
evening, sir. Good evening.
Yeah.
Yeah, I'm Dr.
Good evening,
Komathy.
sir. Good evening, sir.
Good evening, sir.
I'm
Good evening.
Dr. Komathy, Chair,
Okay.
DSCI Chennai chapter.
Thank you, madam, for
welcome.
giving me this opportunity to share my
Yeah.
thoughts.
Yeah. Thank you so much because this session is knowledge sharing.
Yes.
We welcome you.
Thank you.
Godfrey, sir, are you there?
Yes, ma'am. Yes, ma'am.
Yeah. Oh, you open and introduce yourself, sir.
I already introduced, ma'am.
Dr. Godfrey, yeah.
Yes. Ma'am.
Okay.
Ma'am, we will wait for.
Yeah.
Some
HR Mogat sir to come.
Okay,
5 more minutes is.
Yeah.
So, meanwhile, I could see Dr. Subburaju, sir, hopefully,
Yeah.
because my senior colleague.
Oh, okay.
District.
Okay.
And I'm not sure, Pathasarthi sir, whom I see here, is from ISRO Computer Center, head of Bangalore, presently in Chennai, hopefully.
Okay.
I'm not sure.
Okay.
Welcome, Sarat. Where are you now? Which place you are now?
Sir, I am everywhere. Presently advisor to Data Security Council of India and advisor to Broadband India Forum.
Oh,
And,
okay.
keep sitting in sets still. Dr. Subbu is kind enough to give me a room here.
Oh, very good.
Presently, I'm sitting there only.
Okay. So you are still in Chennai.
Yes, sir. Yes.
Very good. So what is IOE? We'll know it, no?
It is everything, sir. Internet of
Everything. Everything. Okay.
So maybe I am also trying to learn what it is.
You are very talented, intelligent here.
I know, sir. Thank you for that. But sir, you are still teaching, sir? Subraju, sir?
Now I'm freelancer only.
Okay, sir.
I do courses for Udemy.
Oh, okay.
Oh,
Right.
I have published 3 courses in Udemy.
Oh, nice, sir.
Of course, next book is also coming.
Okay.
I'm working from home only.
Right from ministry days, you were active in academics, so that
Some interest. I had some attraction.
Yes.
I mean, I like teaching
That's good.
and writing books. We were shaped by destiny, not by ourselves.
Godfrey sir? So live streaming can start?
Ma'am, just now I informed sir, he will join.
Okay.
Once he joined, he will start the live stream.
Started. Okay.
Oh, people are joining fast.
So Godfrey sir, did you inform to HR Mohan sir?
Yes, ma'am. Just now I called him. He said
Okay.
yes. Join.
On 6 o'clock he will join. Yeah,
Join, ma'am. Sir has joined.
Yeah.
Yeah, good evening.
Good evening, sir.
Yes. Sorry, there was some.
Good evening, Mohan sir.
Good
Good
evening,
evening,
sir.
sir. Good evening, sir.
Good evening, good evening.
So shall we start?
No, we'll wait for 2 more minutes.
Just 1 minute, huh? Just 1 minute. Just
Okay.
1 minute.
Okay, sir.
One minute. Just hold on 1 minute. Huh?
Good evening, PVS, sir. Good evening, Murli Bhaskaran, sir.
Good evening, ma'am. Good evening, Mohan sir.
Good evening, madam. Good evening to all. Mohan sir, PVS
Good evening,
sir,
all. Good evening. Good evening.
chief guest. Good evening, sir.
Good evening, sir.
Uh, recording we can start, is it? Recording is on. Hello?
Divya, please start the recording. Okay, thank you.
recording is still not yet on.
The internet is slow for you? Try again. Godfrey sir, can you just try? Yeah, it's okay. It's okay. Okay, it's okay. Yeah, thank you.
Yes. Yeah, we will start now.
Yes. Good evening to one and all.
Yeah. Hello.
On behalf of CSI Chennai chapter, IEEE CS Madras section and ACM Chennai, I cordially invite you all to the webinar on securing connected world of IoT and Internet of Everything. Now I request Mr. HR Mohan, Chair, Events, IEEE CS Madras section to deliver the welcome address.
Yeah. Greetings and good evening to one and all. Once again, let me welcome you all on behalf of the organizing units, Computer Society of India, IEEE Computer Society and ACM. Our sincere welcome to the eminent speaker, Dr. Sarat Chandra Babu,
Thank you.
the members and my colleagues from the organizing units. Participants joined the Google meeting and those who are watching the meeting through the YouTube channel. The advent of internet, the introduction of RFID and the developments in machine-to-machine communication set the foundation for the IoT and IOE, which has revolutionized many aspects in our day-to-day life and also impacted many verticals such as manufacturing, retail, agriculture, smartphones, smart grid, smart cities, cyber physical systems, healthcare, and connected vehicles, to name a few. While these advancements offer unparalleled conveniences and efficiency, they also introduce significant security and privacy challenges. Today's talk on securing connected world of IoT and IOE will focus on the essential aspects of IoT and IOE. That basically the IoT is Internet of Things and IOE is Internet of Everything. Security and provide awareness required by common users, empowering them with the knowledge of safeguarding themselves in different applications, such as basically, where they are likely to be directly impacted, like, intelligent homes and connected vehicles. The presentation will also address the significance of the data privacy in the era of interconnected living. So with this brief introduction, the theme, now let me have my pleasure to formally introduce the speaker, Dr. Sarat, who is known to me personally for more than a decade and a half, and to most of our organizing units for several years through CDAC and SETS, that is Society for Electronic Transactions and Security, with whom we used to organize collaborative events. Dr. Sarat had worked as the executive director of SETS Chennai. Earlier to that, she was the executive director of CDAC Bangalore, and she also has the distinction of being the founder director of CDAC Hyderabad. Dr. Sarat had worked earlier in the Department of Electronics, Government of India. Presently it is called MEITI. Earlier it was DEITI, now it is MEITI. Indian Telephone Industries, Bangalore, and also worked as a faculty at REC Warangal. Basically, he is a seasoned researcher, teacher, and practitioner. Presently, he is an advisor of Data Security Council of India, a unit promoted by NASCOM, and is also the honorary principal advisor to the Broadband India Forum. Dr. Sarat obtained his doctorate from IIT Delhi. He has considerable experience of over 4 decades in institution building, leading national level R&D programs and project implementation and coordination, education and training in the area of cybersecurity, IoT for smart cities, system software for high performance computing, e-learning, and ICT for social welfare. Dr. Sarat has led the team of experts in arriving at feasibility study report of India microprocessor. He is currently chairing the working group on cybersecurity of Broadband India Forum, e-learning section of Bureau of Indian Standards. Dr. Sarat has received the prestigious Vasvik Industrial Research Award in 2019 for his contributions to information and communication technology areas. He has published around 80 papers in national and international journals and conferences, and also guided several PhDs to their completion. With this a brief introduction of the speaker, now let me request Dr. Sarat to enlighten the members attending this webinar on securing the connected world of IOE and IoT. Over to Dr. Sarat.
Thank you, Mohan sir. It's a very pleasant opportunity for me to be here and deliver a talk and share some thoughts in this area of what's happening IoT and IOE and securing the world which is connected with IoT IOE. And let me take this opportunity to thank all 3 organizations, CSI Chennai chapter, IEEE Computer Science Chennai chapter and ACM Chennai chapter for giving me this opportunity to deliver this talk, especially to Dr. Komathy, Chair of CSI, and Mr. Mohan, Chair Events of IEEE CS, and Dr. Sakthivel, Chair of ACM and IEEE Computer Science. So I share my presentation at this point of time, and is it okay?
Yes, sir, you can share your presentation.
Are you able to see, sir?
Yes, that is my presentation.
So this talk probably will schedule for 45 minutes, though I have many slides, but I may be quick on certain slides, which would just give you a kind of a quick view on the technology. So we'll start here. I just wanted to say something what Dr. Chidambaram sir, former PSA to Government of India, always tells us. I quote, always work on important problems, important to science or important to society, unquote. So this is just kind of a thought process where our leaders have in India who are responsible to build major departments and arrive at national level technologies which are useful to the common man. So in this context, I just will not go into the very detail, but this is roughly what I am going to speak, a bit of introduction and ecosystem applications protocol and IoT security threats that happen and some case studies, and also kind of layered approach in the IoT security and solutions. And then what is the kind of preparedness, what is the national roadmap in Indian context that's happening, and conclude. This is just to say that, okay, the IoTs, where is S? That's the question asked. There is no S. What is S is security. That means Internet of Things is, if there is no security, it is Internet of Threats. red sort in the bottom says IoT without security is Internet of Threats. So though there is no S, but we have to worry about S. If you go back to the technologies that are responsible for the Internet of Things before we even define what is IoT, I would fondly remember late Mark Weiser of Palo Alto Labs, Park they call of Xerox Labs. He is the person who's a father figure of introducing ubiquitous computing, that is computing everywhere. That is, he defined that as the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. So what it indicates is that today technology, computing is everywhere. And we will not say that a particular thing is a computer. That's what an embedded device, right? Computing intelligence is there, but we don't call it as a computer. So washing machine or the TV or anything that has internally a kind of a microprocessor or a microcontroller. So, and now around us, there are so many such devices. So they are all even into the day-to-day tech life, and we don't even think that some processor is there, some kind of a thing happening and all that. So while Mark Weiser has introduced the ubiquitous computing, there is when we were earlier talking about one computer, many users to one person, many computers. The Kevin Ashton of Auto ID Center of MIT, he has introduced the concept in 1999 that the devices connect and communicate with each other. So these devices are sensors, and the other side there could be actuators. They are real physical devices and which work together. It could be in a home, at home, or it could be in an industry, or it could be an enterprise, or it could be a government organization, or it could be some kind of a water treatment plant, anywhere. So these devices, they will sense. They have the capabilities to sense and process and communicate. So this is defined as a new concept of Internet of Things, and he says that, I quote, "The Internet of Things has the potential to change the world just as the Internet did, maybe even more so," unquote. So this is just to give you a feel that today the cities are expected to be smart cities. We had a 100 smart city project by Government of India, and a lot of activity. Basically, basic objective is to improve the quality of life of the every citizen. That's how the smart cities always work on the various economic sectors or social sectors: water, agriculture, irrigation, transportation. Of course, irrigation doesn't come into the cities; it will go into the smart village, and a number of things, transportation and all those aspects. So now we are talking about connected cars and driverless cars and all that. So this is a kind of an environment we're expecting to carry out in the future. So everything is interconnected. This is a kind of a thing. And when we talk about Internet of Things, so things become the major thing. So I just take a small definition here. I just read. IoT refers to the network of interconnected physical devices embedded with sensors, actuators, and software, allowing them to collect and exchange data over the Internet. So this is a kind of a definition. Now we are talking about, Cisco has introduced a word, Internet of Everything, later, and it talks broadly, while Internet of Things talks about things and networking, Internet of Everything connects things, networks, whatever is there in IoT, plus the processes, data, and people. So it has 4 pillars: things, people, data, and processes. And IoT has 1 pillar, that is things. Both are in common, has the networking. That is, anything that is connected is addressable. Either it could be an IP address of IPv4, or we assume that because of the large number or a very large number of devices, IPv6 is going to be a kind of a norm, if not today, in future. So IOE is once again broadly a concept that encompasses not only things, but also people, processes, and data. It represents the convergence of people, processes, data, and things to make network connections more relevant and valuable. So if you see, right from the definition in the bottom small diagram I have kept, IoT is network plus things. IOE is network plus things plus people plus data plus process. So here, the base pillar for IOE is also IoT, right? It is going beyond that. That is, we are trying to focus on various aspects that to touch people and that will take care of the processes involved. For example, privacy we have talked about, where let us say Internet of Everything considers not only the giving the end application, it also takes care of privacy. Then it has to take care of the latest DPDP Act, and that is to be considered while it is addressing. And people, suppose you are talking about the health application, and you are having a pacemaker or something. So the people are involved, and while IoT has a pacemaker on the kind of a hospital server connected, but here people are also getting connected, and whose the activity has to be monitored, and analytics have to be done, and so on and so forth. So the focus of IoT is primarily emphasizes the connection and communication between devices, enabling data exchange for various applications, such as smart homes, industrial automation, healthcare, and so on. IOE extends this beyond devices to include integration of people, applications, data, and creating a more comprehensive and interconnected ecosystem. So this is basically so if you strictly speaking, if you go into the literature, while Cisco defined Internet of Everything, and before that, we have the machine-to-machine communication. We have Web of Things. So there are various ways of representing connected devices. It is not just devices are connected. The end objective is there should be a meaningful outcome. Finally, if it is an industry, there should be a process control. Automation has to happen. Productivity has to be enhanced. Make sure that any hazardous situations are diverted, so on, so forth. If you see IoT, IOE are there. There is, if we are using specifically for industries, industrial IoT, it is connecting to the fourth generation, Industry 4.0. So now we are, the automotive sector is using very widely the Internet of Things concepts, and we are calling it as Internet of Vehicles. So especially with the connected cars and so on and so forth, internal to the car as well as external to the car, they're all connected, and a lot of technology is being used. In fact, it is going to be one of the fast-moving IoT environment or IoT vertical. It will be the automotive sector. Being in Chennai, we are all in place where Detroit of India, and there is, if you see most of the automotive companies, they are working on using the technologies. Definitely the CAN kind of things are the control area networks and so on and so forth. Beyond that, so they are also worried about the security aspects, and it would come. We'll go into that little detail later. This is just to give you a feel that Internet of Everything, as Wipro has defined, it is connecting. If you can see these circles, it talks about everything. Right, decentralization of business, decentralization of work, distributed ledger. It uses the blockchain, analytics at the edge. There is edge computing is also part of it. Internet of Things anyway is part of it. Distributed information capture, security at the edge, and so on and so forth. So it considers even the cloud. It considers the fog, all that hierarchical thing. Internet of Things, the edge computing, fog computing, and the cloud computing, all will be considered as part of the IOE. And this is the definition given by Dave Evans. Okay. Yeah. I am just bringing a small analogy. It's my favorite slide. So like water cycle, you know that the evaporation happens from the water sources and the transpiration from plants and all. Finally, the clouds are formed, condensation, precipitation, and we get rains back. And then once again, catchment areas, the water will be there. And that cyclic process of water is how it is in natural. We also have the data cycle where IoT is playing a major role. Here you can see that the clouds, here you can see the clouds are our Amazon Cloud, Google Cloud, these kind of clouds, and which address the big data. They collect the data like what happens in the water cycles. They collect the data from the sensors that are put in the distributed, geographically distributed areas, and those sensed data would come through the edge computing or edge computing or gateways and go through the fog and reach the cloud, and finally they do the big data analytics and do the APS A to Z services in the cloud, and finally the solutions to improve the quality of life that the mankind is envisaged. So basically, it's an integration of IoT, cloud, and big data, helping the enterprises, helping the society, and so on. This is a lot of statistics keep happening. I just have one such a thing here. We know that quite some time back, there were statistics by 2020, what happens 50 billion, but it didn't happen. But now it is moved to 2030. It is expected that 50 billion devices will be in use. That is one of the big thing is this particular area, large number of devices. So every device has to be uniquely identified. So right. So this is the kind of a challenge that's going to happen. And it is expected by 25 that 152,200 IoT devices will be connected every minute. So these are the kind of statistics we get when we Google and get through different statistical groups. They give different numbers, but it gives a general feel that yes, there is going to be a large growth, enormous amount of growth, and the devices vary from routers to cameras to sensors, everything, right? So if you can see the application domain, as Mohan sir gave an introduction beautifully, almost he mentioned all: manufacturing, healthcare, smart cities, communications, transportation, agriculture, to say a few here. So this is just to give you a feel that there are some IoT systems developed in CDAC. This was few years back. They used IoT. They developed, if you see right-hand side bottom, they developed modes. There's wireless sensor networks, which becomes a part of an IoT device. Each mode will have a sensor. It could be a humidity sensor. It could be a temperature sensor. It could be, the related to weather monitoring stations like wind direction, wind speed kind of a thing. So all these sensors are developed on a mode. Mode has the processor, microcontroller, and it has the sensor. It also has the radio. Okay, so the radio, there are various systems. You use basically RF communication. They go through Zigbee kind of a thing up to layer 2, or it will go beyond that. And we have parallel solutions for the local area networks like Bluetooth Low Energy and Wi-Fi itself widely used now. So there are so many protocols that are used at the physical layer and next layers as well. So here, just to give you a feel, early fire detection systems in tall buildings, multi-storied buildings. So the IoT devices can be connected, and based on the temperature variations and the flame recognition systems, and also because it's early fire detection, so they will even see the switches getting heated, and based on that, they anticipate that there is going to be a spark or it can result into the fire. So such things to identify. So this is one thing. In center, if you see, there is one, I think Harita Priya project, which is a AP government project in Kurnool district, where 25 villages were connected for their groundnut crop, and in each agricultural area, a number of sensors were put, basically soil moisture, humidity, temperature, leaf wetness, that kind of measurements were done. These were through these sensing wireless sensor networks, they reached to a wireless sensor network gateway, and gateway is connected to a remote server through a 3G network or a 4G network. And so this information that is coming is given to a model. The model will run, and finally it gives what is the crop water requirement and what are the fertilizers required. So fertilizers required will be the decision that was taken to that farming area will be transferred sent to the farmer's mobile phone in the local language. So it's an end-to-end system. So here is a very good example of an Indian context where agriculture is one of the main sector. So this pilot was quite successful, but it requires, there are a lot of other things like physical security of the devices and who will bear the cost, these kind of things. But now the kind of governments are doing pioneering effort in advancing technologies and their uses for the various sectors like agriculture, water, health, and all. So we expect that this kind of pilots would help us. And you can see in the bottom, smart water distribution system. There is a water sector challenges they have conducted, and many private sector companies have joined this, and they have deployed applications which could be used on this IoT kind of an environment and come out with solutions. So this is just to give you a quick idea of IoT framework. There are things that is sensors, actuators, RFID, and so on. They're all connected, and they would collect the data, and that would be used by kind of a machine learning kind of algorithms for classification, anomaly detection, etc. They learn, and then finally they do what is to be to improve the quality of service, reduce consumable costs, and use new business models, and so on. So this is a quick 5 steps. Things will connect and collect the information, they learn, and then they do the required job. This is in another form. It's an IoT ecosystem. Here, it of course gives you what are the various sensors, examples, data processing, data collection, software information, smart applications, as mentioned, smart homes, lighting, cost, farms, buildings, so on and so forth. Intelligent services. What finally they do is asset tracking, efficient transportation, environmental protection. For example, in operator-independent truck dispatch system, if we use an IoT in open-cast mines, the very heavy machinery, if they are not properly being utilized, somewhere they are idling, so they can be, they will come to know, they track these assets and make sure that they are transported efficiently because they are very expensive, and make sure that it is optimally utilized, the resources, expensive resources. So these are some examples. And air quality control is considered to be one of the key things in the environmental things, especially the cities getting choked. And this is a need of the hour, and kind of you are able to use very systematically that would improve the quality of life. Right, supply chain automation. We know that supply chain issues are there everywhere, and IoT devices would help in the connecting the supply chain system and automate this right from inventory control to the final production. The things can be taken care. So if you see in the bottom definition, once again it comes. What differentiates IoT from other electronic technologies is we know that they're all remotely operated things, and they're mostly battery operated, so low power, and they will have resources, low memory, and low power connects to the power of the battery as well as the processor power, and constrained operating environment, even the network speeds. So fundamentally, they are wireless, and multiple emerging wireless radios are being used. And sensors and actuation, because not only sensing, finally, in a process control kind of an environment, you can automate. Even at home, after sensing the temperature, you can automatically enhance the air conditioner cooling, or you can reduce this, and so on and so forth. Right from home to smart homes to industries, we can use the sensors to actuate the complete process control loop. I'm not planning to explain everything, but just to give you that there are so many wireless protocols, wireless being the medium of communication. And you can see that Wi-Fi is going to be there, and it's going to be widely used. The only thing is its consumption of power is much more compared to other. Zigbee is specially designed for the low power kind of communications. 6LoWPAN is also specially designed for the low power. 6LoWPAN stands for low power, and 6 stands for IPv6. It utilizes IPv6 and personal area networks. And Bluetooth local energy, low energy, they are used once again for the low power communications, and very small range, short ranges. When it comes to Wi-Fi, it's reasonably more. Zigbee and all would go up to 100 meters and so on. LoRa is for the long range, which is a proprietary algorithm that's widely used for long range communication in IoT environments. These are, to say, a few popular protocols. And this is just to give you an edge layer, the device layer, IoT device, and then we have an edge layer. Mostly gateways and all would come into picture, where one side of the edge is the various Internet of Things devices. The other side of the edge is the communication links going to the cloud. And internal to the edge, it will have more computing power, so it will be able to do the local processing to offload the computing one end from the IoT device and another end from the cloud. And people probably, when there are a lot of data, what they can do is in the edge nodes, they can put the machine learning, to use the federated learning kind of things and aggregate them at the cloud to arrive at the intelligent decisions. So till now we have just spoken about various aspects of Internet of Things, and what are the various technologies, protocols that come into picture. Now we'll just, as you know, the Internet of Things and Internet of Everything is once again a networking, and mostly it uses the internet. So whatever security breaches happening, whatever security worries that are happening in the traditional networks are going to be there in IoT environment. In addition to that, because of the nature of the devices, because of the way they were progressing, various manufacturing, implementation weaknesses, the threats are much more. That's where when we say Internet of Things, if you don't worry about the security, it's going to be Internet of Threats, right? So I think everyone speak about Mirai botnet. I think that because that gives a very wise or open the importance of securing the IoT devices. I'll just give you the diagram explained later. So in addition to that, there are health-related US Food and Drug Administration recalled pacemakers because of security issue. Tesla model car was hacked from 12 miles away through a CAN bus attack. And IoT Reaper is a botnet which is considered to be more dangerous, and they were targeting unpatched vulnerabilities because the patching, that in traditional things, every day, a lot of patches come to us at operating system level, at applications and so on. But how easy it is or how difficult it is in IoT devices, which are, from different manufacturers, and they're at remote locations, the patching and constrained resources, how effectively we can patch them. So if most of the devices are left open and unpatched, so they're the major source of attacks. Okay, so some of these points is mentioned here. What are the security challenges in IoT devices? Incorrect access control, large attack surface. The surface of attack, as I mentioned, it's growing because of the large number of devices. Outdated software because we are not updating. Lack of encryption. Most of the time it goes through the open channel, telnet ports, this kind of ports. If you see the attacks that happened in Mirai and all that, it's because of the non-encrypted channel through which they were able to identify, attack the systems. Lot of software vulnerabilities and so on and so forth. Insufficient privacy protection. Physical security is one of the challenges. As I mentioned to you, in agricultural application, you leave it free, and nobody knows the importance of it. Simply, they will throw a stone and it is gone. So you require a lot of locking, and that requires physical security becomes an expensive thing. So these are something, and some statistics once again. 98% of all IoT devices network traffic goes in plain text, exposing sensitive data on the network. And IoT devices are the low-hanging fruits for the adversary because many things were not taken care of, what was taken care in traditional thing. So they will be able to easily identify the possibility of vulnerabilities and attack them. And they have medium and high level security attacks as well. And 41% of attacks exploit IoT device vulnerabilities. So Mirai attack is just explained here. If you see the bots or the army of things who will become an army to attack a victim, and there will be a command control center. And command control center is actually when it finds a vulnerable bot, it will address as a step one, existing bot discovers new open device. A device is open through its ports. and that open device information is coming to the command and control center. And then that is a second step. In a third step, CNC copies virus into the new device, and CNC commands the bots to attack a victim. It is not that bots are getting affected. They are being used as a weapon to attack the victim. Finally, all these bots are going to do some kind of an attack where it could be a denial of service attack or distributed denial of service attack. So the Mirai attack here is exactly the using the denial of service attack. It took advantage of insecure IoT devices in a simple way. It scanned big blocks of the internet for open telnet ports. The telnet ports open because they are mostly plain text. It is easy for you to look at, and they are all using the default passwords, and so they are able to attack easily and take control of many bots and attack the victims. So this happened. Mirai botnet tested its capabilities by causing its millions of digital video recorders, routers. These are all the devices having the default passwords and all. So they were able to take control of them and flood the DNS service provided by a DIN company with requests by overwhelming it with requests such a way that the services of the popular companies like PayPal, Twitter, everything has gone haywire, and it was a major incident. And so the need of the thing is to make sure that the password default passwords should be removed, and you have to improve that, and then you have to enhance the updates. You have to do time to time, and not encrypt the data that is communicated. Data is in transit, data is in storing, data in use. We have to encrypt in all angles. So these are few things that immediately come, but we'll see the systematically. So when you talk about cybersecurity traditionally and cybersecurity in IoT environments, how they differ, this block diagram explains. It's a diverse ecosystem. You know, there are a lot many manufacturers, and each one, and if you talk about a particular solution, there will be 100 manufacturers using different standards. They comply or they may not comply to even the standards. So they will be mostly hardwired passwords will be there. And so it's going to be a diverse ecosystem, and resources are constant anyway because they are remotely battery operated. The processing power will be less, and you have to make sure that memory will be less, and you need to take care of if you want to use security solutions are resource, they require resources, they consume rich resources of processing, memory, all that. So there is, how do you handle this? Resource constraints, heterogeneous communication protocols. It is not just TCP/IP. You have seen just now Bluetooth, low energy, Bluetooth, and then the Zigbee and 6LoWPAN and Wi-Fi. All possible communication protocols are being used. And if you go into the field devices, there will be other kind of things, Modbus kind of things you have to understand. And firmware and software updates. In all these devices, the firmware becomes an important thing. In fact, firmware attacks, for most of the time, attackers will retrieve get the firmware using the standard tools and understand, deassemble the codes from the executable code to assembly language or C language, whatever, and then understand the vulnerabilities and attack. So the firmware and software updates happen. This is because attacks are happening because we are not able to update. How to update them is a big challenge. Because they are large in number and they are also in different locations. So how effectively we can do this updates. So the privacy concerns, because almost IoT devices are into the personal areas. We are talking about smart homes, and anything that is all connected to the people. So personal identifiable information is easily accessible if you're able to attack the IoT systems. So how do you address the privacy concerns? How whether DPDP Act anyway helps this? Physical vulnerabilities. So physical, as I mentioned to you, the devices, can be taken care. Okay. This is just to give you an idea of smart home IoT devices. And so here it says that what way you can handle, how to secure. change default settings. So it is the first thing you have to do is you have to make sure that all your default settings have to be changed, and you have to use your own hard passwords. And once you have a lot of devices, you must have a way of managing the passwords. So using the password managers. Okay, there are different tools that are available. Trend Micro Password Manager is there, and so on and so forth. Many tools will be available. And multi-factor authentication. You don't just satisfy with the password. Also use more kind of a code assigned to that, like OTP kind of a thing. And use at least two-factor authentication to be far more effective authentication. Control access, limit the number of people. That is, you should not allow everyone. Suppose for example, you come to the smart speaker should only recognize your voice. It should not recognize any voice and then do what it is supposed to do. So control access, and also control access to the people to various things. And if possible, you try to separate the networks in that what are the critically important and what is not critical. And update the software time to time. Check smart device apps. That is, we should not download every app. We need to make sure that those apps and what are the security, privacy things taken care by these apps have to be understood and taken care. These are some of the points that one has to address when you are dealing with smart homes. And you have to secure the routers, monitor connected devices, set up separate networks. Setting up separate networks is an important thing everywhere it comes. So a network which is okay, even if somebody attacks, no problem. But there are certain portions of a thing, if it is attacked, it could result in the fatal things. So you have to separate that kind of two types of networks, critical networks and the normal networks, devices which are connected. Even if it is affected, no problem. So the smart speakers, you need to make sure that limit shared data, check connected devices, review recordings, control voice related features, and so on. So this is just gives you in a smart home. We use a lot of tools and a lot of devices, and how do we may take certain level of thing. So this is just to give you, this is what is prepared by CDAC. They have a program called as Info. I thought it is also an important information for you. They are having a program under Ministry of Electronics called as InfoSec Awareness, Information Security and Education Awareness, InfoSec ISCA program. Under that, they have an awareness exclusively for different domains and different set of people. So they develop this kind of posters and brochures and all that for the canvassing and for creating awareness and to share to the people, right from the NGO organizations to government organizations to the police, everywhere. They share this into multilingual thing. You can see one such an example. Smart speaker can be a smart spy. So it says enable voice recognition to recognize only your voice while giving commands. Be careful what you share. Do not share personal and sensitive information. While sharing that, also you make sure that the information should not be sensitive information. Make sure your Wi-Fi is encrypted. Wi-Fi is the most dangerous thing. As such, in fact, default, if you have a WEP security protocol, that is wide equivalent privacy protocol, it won't help. You have to go for the latest WPA protocol, that is Wi-Fi protected access protocol, that WPA 2 and now WPA 3 is also there for better, crypto strong algorithms. So you have to look at, depending on your requirement, you have to see Wi-Fi is properly encrypted using the proper security protocols. So be watchful about what you connect and avoid connecting to door lock or surveillance camera to prevent thefts. So these are a few things we normally do, and we must make sure that not in use. Enable notifications via email or phone. This is another that is the smart home related example. And as I mentioned to you, automotive sector has started, and the amount of electronics that is being used now, it is a computer on wheels. Now the people call the car as a computer on wheels. And the lines of code that in advanced cars will be millions of lines of code is there addressing various operations, right from the control area network, right from the brakes controlling to the fancy items like music systems and belts, everything, all are controlled and this particular through the various microcontrollers. People say that there will be more than 250 microcontrollers in a given automated car. So this is a kind of an environment in which automotive sector is moving. But we found that initially when the cybersecurity was not thought of, because they went with the conventional using electronics but not looking at the security aspects. This is one such an example, relay attack they call. There you know that the cars, using the fob, you can open remotely without entering. You don't need to manually open the doors and manually switch on the ignition and so on. So what we here, there are two thieves involved in taking the control of the car. So first thief stands very close to the vehicle and uses the device to relay received signals to the second thief. He will relay through his device to the second thief who is nearer to the home. It is expected that the car keys are in the home and owner is also in the home and the car is here. And this car will be generating some signals which is captured and replayed and sent to two. And the second thief, because he's very close to the front door holding the device, this device retransmits that inside the house, and the house thinking that genuinely it is coming from the car, it responds. So in this process of communication, they capture the things and see that how to open the door of the car, and after that one more relay attack they will do to initiate the ignition as well. This is happening because the car keys were kept in a way that the electromagnetic signals are easily entering and you are able to connect. For that, you can do some tips here, considering purchasing a Faraday pouch, which is it will stop electromagnetic interference and electromagnetic signals of some type, and so that this kind of replay attacks won't happen and relay attacks won't happen. So, and also see whether we can switch off the fob when you are not using it from the manual, and to the extent possible, avoid them to keep it at the entry points, because entry points is where, as you can see, the thief in the picture is very close to the door. And normally we keep keys, as soon as you enter, we keep right side somewhere, we'll have the key hanger and we'll keep it there. So this is just a small example. And a lot of such attacks have happened. And as in the initial thing I mentioned, they have to they have to recall many cars and rework for taking care of the security aspects. So this is problem here is, it is normally security in systems are okay. It results in the financial losses and it results in the reputation of the companies and so on. Here we are dealing with an automotive car. If the car is traveling with the passengers, and if you are able to take the control of the cam, and if you are able to take the control of onboard diagnostics, and you are able to apply brakes or enhance the accelerator, you can do anything, and it may lead to fatal accidents for the people who are inside the vehicle as well as the people who are traveling in the other vehicles or pedestrians, anything. So this is a very serious thing. So automotive sector, because they widely used all these devices, Internet of Things kind of devices, because they're all based on sensing and finally controlling using the actuation. So this security has become very, very important, and they have come out with some standards. So this is just to give you a sense. I'm not going into the details. You can see many possibilities of attacks, man in the middle attacks, through RF links, side channel attacks, vehicle to vehicle hacking, and a lot of malware attacks. Third party apps can be compromised. Okay, so many things. Okay, so this, as you can see left side, malware and hacking, data breaches, supply chain attacks, and the human error related things. What happens in traditional things would also happen in the automotive sector. So what do you do is security, because automotive sector is not only security, safety of the people, safety of the equipment, safety of everything is involved. You have to have the security by design, that is defense in depth. Every layer, say security by design and also defense in depth. That is, at every layer you have to take care of security. And security by design is an important concept cutting across all areas that is being promoted. In the design itself, if you are taking care of security, security should not be afterthought. and security as a board should not be there. Security should be part of it, the system. Then your solutions will be stronger. So you can mitigate the potential vulnerabilities and so on and so forth, right? So it's an important area. There is a lot of research happening, and even in our IITs, IIT Madras, formal verification methods and all they're employing to arrive at security by design principles. So defense in depth is once again to how at every layer, it is a physical layer, CAN layer, you have to take care, and it's a middle layer network, CAN controller network layer you have to do. And if you're connecting through a kind of Wi-Fi or LoRa from this car to another car, so there you have to talk at network level, transportation layer, and applications that you are talking about. So you have to take control of that. And standard compliance. This is one of the key things. In fact, these three things can go a standard way of securing things: security by design, defense in depth, and standards compliance. If they are all followed, you are more secure. Okay, you can avoid to the extent possible security breaches and so on. You can see that as SAE, Society of Automotive Engineers, along with ISO, has come out with a standard 2021 214 ISO/SAE 21434. That is the standard name. It is now the standard available for the cars on the roads, everything, and it is accepted as an international standard. Now there are a lot of activity happening in this standard compliance by the automotive sector. And what are the three things to mitigate? Just mentioned is you have to have security testing, like what we do for the VAPT services. I think we need to do for this IoT kind of environments also, penetration testing and bug bounty programs kind of thing we have to do. Supply chain security, because this automotive sector, wherever IoT is in to end-to-end application, there are a lot of suppliers, a lot of components will go into that, and finally the different people will come and work on systems and applications. And in supply chain is very long and very large number of players will be there. So you need to make sure that this supply chain security, everywhere security. That means you have to, if you are a main manufacturer, you should tell your suppliers that you follow these standards. So those standards are also available, and one has to know how they are followed. So for these things, in fact, I will be mentioning somewhere, there is a National Trust Center is getting established by Department of Telecom using the CDOT expertise and Telecom Engineering Center expertise to make sure that most of these devices for the trust requirements are registered and comply with the standards and so on. So our devices, software developers, the system developers, and everyone how to become part of it. In the component supplies, individual discrete components, those who supply, they also can register, which will go into the IoT devices. So in addition to that, the employee training, because these are all new concepts into new automotive sector to home. At home, normal, common man. Some small tips I have mentioned for using the smart home things. So the common man also has to understand the security risks and how he can control the things. So there is a lot of employee training, and there's employees when they're selling the devices, they should train the users. Similarly, if you talk about the bank employees, when they are training people, when they're connecting to the people, they also have to train the users, customers who come to the organization when they are using the smartphones for their banking applications and so on. This is just a kind of a repetition, though I probably skip, but only one important thing here is OWASP is an organization which comes with a lot of standards. They have come out with IoT top 10 issues which have to be addressed, which few we have already mentioned. We have to make sure that weak, guessable or hard-coded passwords should be avoided. That is number one. Insecure network services should be removed. Insecure ecosystem interfaces. Insecure network services, you can say, if they are on a plain text, they are not encrypted, such service is insecure. And insecure ecosystem interfaces. You are secure, but other side is not securing. So you have to make sure that in your ecosystem, every interface is secure. Lack of secure update mechanism. use of insecure or outdated components. So in some of the systems, so how do we handle it, right? So these are some of the things. I don't want to go into everything, but these are devices. So I think there are some more.
Sorry, sir, you're muted, sir. Correct, sir, you're muted. Sir, you're muted.
Oh, sorry. Since how long? Just now or?
Just now, sir.
Okay. Sorry. One.
Sir, just open your PPT slideshow, sir.
I'm just, I'm not able to open it. Just one. Yeah. No, the presentation back. So I think it's a kind of a, are you able to listen and see?
Yes.
Sorry for that. So the how to address IoT device vulnerability, some points are here. Be careful in choosing the devices, map and monitor all connected devices, understand each device accessibility setting and permissions, use network segmentation as I mentioned to you earlier also, disable unused functions. This is an important thing. Disable unused functions and connections. So this is these are few tips for the IoT devices. This just gives you an example. If you have an application, let us say smart home or automotive car, you have, let us say, if the operating system is Linux, it may take 25 million lines of code. Windows may take 50 million lines of code. If it's a car-related application, that it will take 100 million lines of code. As the code size is increasing, the complexity is increasing, the bugs, vulnerabilities increase, so attack surface also increases. So the risks of privacy, safety, denial of service attacks will happen. Denial of service not only happens to you, that is attack a device, through you, it can attack other devices as well. So this is just to give you a thing that at home, if you have an application, how do you secure? You make sure that your credentials, password, everything is proper, user ID, password, everything is proper, and have the network segmented, as I told you, to 2 parts or multiple parts depending on their security requirements. So one is highly secure, one is middle level secure, and so on and so forth. And patch all with the latest softwares, and make sure that principles of least privilege is followed. That is, not everyone is given the privilege of going to the root or something like that. So make sure that when you are not using certain devices or certain functions, switch off them. So these are at home. Right? When you come to the office, it is not as simple as home. All these things you have to do in office as well, but there will be an office strict policy will be there. The policy implementation is an important, policy enforcement is an important thing, and employees should be trained on this policy. If you see, everything at office is related to the policy, how effectively you are following the policy. So train the employees, enable that this policy is implemented, and discover any new devices that are coming into the network, and make sure that you enforcing the policy. So this is just to give you a quick idea of at home and at office, how an IoT environment can be secure. These are just standard traditional security frameworks. I'll quickly move. So it addresses access control, authentication, non-repudiation, everything, NIST security framework, right? So this is a kind of a framework which is more suited to, I do not know the source, but Dr. Sudarshan of CDAC is to share this, and he agreed for me to share also. So it talks about code security, device security, communication security, security configuration and management, security monitoring analysis. This is more suited for an IoT because it talks about device security, data protection, port security, communication security, and monitoring, how effectively you monitor and configure. So here once again, you have layers. You know traditional layers, right? You know network layer, application layer. But there are two new names comes in this, unlike OSITC pairing, there is a perception layer. This is the layer where all your sensing is a physical layer, but which has sensors for sensing and gathering information about the environment. It senses some physical parameters or identifies other smart objects in the environment. So this is something, an important thing. And here, a lot of attacks will happen like eavesdropping, RF jamming, tag cloning, and spoofing attacks will happen. So network layer traditional attacks happens, the denial of service attacks. Civil attack is the fake nodes were created to give an impression that there are many such similar things, and it will confuse the network and disturb and finally affect the functionality. Sinkhole attack is another thing. A node will become, it is able to attract all packets that are coming connected from the connected nearest neighbor nodes. And there are many variants for sinkhole, gray hole, wormhole, and black hole. Black hole is whatever packets it comes, it totally consumes. It will not send it back. Whereas in wormhole, gray hole, it will certain selective forwarding it will do, still holding certain things. And in the wormhole, it creates a very hot connection between two very remote distance devices to give an impression that they are very close by having a high energy connectivity and so on. So these are a few things. Man in the middle attack, replay attack. Replay attack, what we have seen just now for the automotive sector. And middleware is another layer, which is just above the network layer and below application. It's close to, transport layer. You can see the attack also, threading attack. Synthread attack is a standard thing, right? The three-way handshake getting affected. I'm not going to the everything, like application layer, you have the code injection, buffer overflow, phishing attacks, and so on. Buffer overflow seems to be an unending problem because we know this buffer overflow a long time, and we know that it is because basically in C, you don't give the buffer dimensions, then overflow is into the usable code, and people will attack with malwares by writing more into the buffer beyond the dimension because there is no dimension restriction. So this is one thing which is requiring secure coding practices for use. It will take care of. So an important point here is the secure coding practices for the developers have to be done. And so these are some of the attacks at different layers. This is one way of looking at the thing. There's another methodology by Juniper Research, close to that earlier architecture I have mentioned. Excuse me. There are, sorry for that, 1 minute break.
No problem, sir.
That's it. You can meanwhile observe this diagram. Sorry for that. So here,
Sir, you just relax and start.
Yeah.
Just relax.
sure, thank you. Here, IoT layers are divided into 3 layers: devices, gateways, networks and connections, and cloud applications and users. So each one requires different security requirements. They are mentioned here. That is, for devices, we need device identification and authentication, and a firmware code authentication, communication, data encryption. The data encryption has to be done. When you come to the gateways, their communication data encryption, message verification, because there are lot of messages in the gateway level. When you come to the applications, it is a code verification, user system authentication, data encryption. And overall, entire key thing is security lifecycle management is an important thing in IoT as well. Like we have the software engineering practices for the traditional systems. Here, secure software design practices, secure hardware design practices have to be done, and entire thing, all devices, everything have to be in this lifecycle management. Lifecycle management covers in the devices become obsolete, devices requiring the patching, to gateways addressing the required protocols and providing the speeds and required encryption mechanisms and so on, and cloud applications and users to provide services. In fact, Amazon and Google and Microsoft, in all their cloud applications, they have IoT core things like hubs. They create IoT hubs, which are providing a lot of services of this patch management and password management and so on and so forth. So here, now next 3 slides give you more details on each layer, how you take care of the triangle of confidentiality, integrity, and availability is taken care with different solutions. You can see, I think I will be sharing this presentation, so I will not go into the details here. Cryptographic authentication is a trusted execution environment. You know, this is an important point. Trusted execution environment normally provided within the processor, which takes care of the keys and the key cryptographic functions. Part of the processor itself, and secure element, which is once again isolates cryptographic functions and by a dedicated hardware. And hardware security module is a separate module for high-end servers for secure key management and crypto processing will do. So the lifecycle management, data encryption, and so on. These are for confidentiality. A lot of crypto algorithms would be used here. One of the key things in the IoT is you have to go for the lightweight cryptography. If we have some time, we'll see. I think time already taking more time. Let me see how much time I have. Okay. See.
Sorry, take up time, sir. It will be 7:12. You can go up to 7:15.
Okay. 10 minutes. Right.
Yes, sir.
15 minutes maximum. Okay. So protecting integrity solutions for that is security booting, secure booting, message authentication, data encryption, digital certification signatures, where all they were taken care is mentioned here. I request you all to go through this. For example, secure booting is not required for all layers. It's only required for devices. And similarly, digital certificates and signatures, which is a very challenging thing for the IoT environment, also required for devices. The PKI infrastructure that once again, the algorithms that are involved and the kind of signature methods and all integrity checks, they take a lot of resources. So how do you handle it in this resource constrained environment? So similarly, availability solutions using the firewalls, IPS, IDS, DDoS prevention services, these are all available to us. These are at gateway. You can see that they are required for gateway networks and connections. All availability solutions, traditional firewall, IPS, IDS, DDoS, were required for that central layer, that is gateways, networks, and connections. These are some of the things we have been mentioning while talking, that these are key things like network security using those devices, IoT authentication, IoT encryption, encryption specifically through lightweight algorithms, PKI special infrastructure methods we have to use, security analytics we need at the cloud level, API security. IoT API security is a key thing. We need to address those challenges. It's an important concept. I thought I'll share it with you. It's one of my PhD students studied for the IoT security, talking about the positive and security model and negative security model. In a positive security model, you normally known good is whitelisted, and remaining things are not known. But known bad, known good. Remaining are unknown. But in a positive security model, you will only see that known good is whitelisted. Only those applications are allowed in the IoT environment. If you come to the negative security model, known bad is blacklisted. All remaining things are allowed. But in that, we don't know. There are a lot of known good is there, but unknown are also there. If you are only blacklisting, you have a risk of in unknown things, there could be bad ops, which you have not blacklisted. So these are the two models, positive security model, negative security. If you see this diagram, right, at a home PC kind of environments, negative security model is used, blacklisting model. But in IoT, embedded systems, mission critical environments, there is a whitelisting model is used. So this is very, because you don't have many functions in a way. Most of the times IoT devices have to do a specific function. So you only whitelist that function, don't allow any other function to perform. So that you are controlling the attack surface. So we just mentioned some of the devices in IoT hardware. I'm just skipping this. So lightweight cryptography is an important thing. There are special protocols. Some I mentioned here, present, Simon, kind of lightweight block ciphers are there, and hash functions are there like CIFHASH and Photon, and lightweight authentication protocols for the integrity check, HMAC and SPEC are there. But what are the characteristics of security? Low computational overhead should be there, low memory footprint, fast execution, energy efficiency. These are all the things which are required for an IoT device, for any software, especially cryptographic being an overhead on the IoT functionality. You need to make sure that they are not consuming the resources. This is just an example of typical one of the students has compared using the two protocols, using the software method and some on the directly on the hardware. So if you use hardware, for example, MSP430 based hardware was used with 16 megahertz and 3.6 source supply. So if you can see the timings that are taken here, the idea here is algorithm for what we used. If you can see that there are different algorithms consuming, and you can see AES-128 hardware is efficient compared to implementing even the spec present, which are specially designed lightweight algorithms. To AES-128 is not specially designed lightweight, but being 128 key size being small, it is more applicable for lightweight. In that, if you can see that hardware implementation is quite effective, mentioned here. So this is just to give you an example that there are a lot of protocols that are coming, they are getting standardized, NIST is standardizing, and various organizations are standardizing, and now they're in the final list. There are some more, I think, some work is happening, but mostly for various functionalities, crypto algorithms are getting finalized. There are some best practices here for securing devices, make hardware tamper resistance, provide for firmware updates, perform dynamic testing, specify procedures, etc. Securing networks, use strong authentication, strong encryption, minimize device bandwidth, divide networks into segments. When you come to secure the overall IoT system, protect sensitive information, encourage ethical hacking, institutionalize IoT security and privacy certification process. So most of the time, you have to make sure that there is a certified IoT security professional course like other courses. So one can, those who are handling IoT systems can be trained in this. I think a lot of things are there. AI can be used, AI can be used for many. I just quickly mentioned that it's for threat detection and access control. It will enhance these features, predictive maintenance, vulnerability detection, zero-day attacks it will detect, and used for network security. And mainly it will provide improvements in anomaly detection, real-time threat detection, because of the speed at which the AI solutions can work. Real-time threat detection, especially the zero-day attacks, can be easily identified. And malware detection, it will be able to see even the smallest change that is happening in a very large data. Consider the threat canvas is an image in which a new threat that is coming will be more or less following the earlier threats. So it's easy to detect using the AI techniques, proper machine learning techniques, the detection of the thing based on the behavioral analysis as well. So blockchain is one thing. Without blockchain, no security can happen. So it is, once again, IoT is also has no escape, but there, once again, the resources required for blockchain is very enormous. In fact, one of the questions are towards that. There are special platforms like IOTA platform is lightweight data transfer protocol. It uses the feeless transactions, scalable solution. So compared to Hyperledger, it is useful, but Hyperledger provides enterprise grade IoT deployments. So these two are important things. And also you can use the proof of stake instead of proof of work methods in the, when you are accepting a particular data into the links. Because there it is not accepted, there is no puzzle based and there is no competition and all that. Some nodes are automatically selected and they were allowed to update the data in the links. So these are few things in blockchain. Quantum is also used in security, quantum key distribution, post-quantum cryptography solutions, because quantum attacks can happen even on IoT. So post-quantum cryptography algorithms, which are of lightweight in nature, already NIST round 3 is over and a few algorithms are there. And now people are doing research on lightweight post-quantum cryptography algorithms to be used here. And quantum key distribution for secure the transfer of the key is also being used, and a few of these things were mentioned here. This is an important thing in a hardware security. If you are using an IoT device for authentication as well as the secret key, you can use a concept called as a physically unclonable function. Basically, it's a small hardware which will be able to develop based on the hardware chip features like oxide thickness, doping, feature size, etc. You can arrive at a signature of the chip, and that could be used for device authentication, or that could be used as a secret key generation. There is no need of storing here, so there is always secure. And authentication, because every device will have different physical parameters, it is assumed. So chip 1 and chip 2 of the same manufacturer batch will have different responses. So that way authentication becomes possible. This is an idea which is being, there are different types of puffs and more suitable puffs are being addressed, and it occupies very less hardware space. It can be integrated into the hardware design as a system, design security by design concept. It can help. Some of the ideas like zero trust model are applicable here. Zero touch provisioning is an important thing, like automatically configuring large scale devices. Scale is an important concept, so that can be used. Digital twins, because of the IoT devices very large in nature, geographically spread, you can't go and see the things. But if you have the software version of the model as a digital twin, and whatever changes that you implement and what changes happen here, what changes happening in the physical world can be brought here and see what is the problems, and you can make use of them for maintaining the systems and enhancing the security and so on and so forth. There are a number of standards. ISO has published security and privacy guidelines in 27,400 series. 2022, very latest. 2023 is also device-based layer ICT requirements are given guidelines are coming as 27,403 and so on. There are many protocol things. Compliance now, because they are getting published, the compliance also become important. Automotive security, as I mentioned to you, ISO SAE 21434 in the year 2021. And these are some listed things. There are many groups of companies came together and came up with a lot of standards. So you can probably see, but finally we know that standard bodies have to do. And in India, Broadband, BIS, Bureau of Indian Standards, is having the IoT security working group, and they're working very hard and looking at the ISO standards, international standards, and also looking at the possibility of Indian standards to implement in the thing. So some of the research directions one can consider here. This is a slide given by Professor V.N. Sastry, IDRBT, in his presentation recently in one of our IoT security acceleration program of Data Security Council of India. I just picked the slide. Some of the areas that would be of interest to you, because most of you are from academics and students and research students. It would help you to look at some of the areas where you can function. There are some national efforts quickly to mention. There is a roadmap arrived up to 2047, what has to be done in IoT security. In many fields, they have done MATI, and I have given the link. I'll just display one diagram also. There is an IoT security handbook developed by CDAC with the help of MATI and STQC. It gives you the total testing, how it has to be done and all. NITI Aayog also has come out with the 5G IoT versus cybersecurity articles, and NCOE of DSCI, the Center of Excellence, together they arrived at IoT Security Guide in 22. And there are key R&D projects. National Trust Center, as I told you, it's going to be an important thing. Intervention from the government. Once this is there, they will insist on for all critical strategic applications, the devices, IoT devices have to get the certification, get the trust certificate from this National Trust Center. There is another R&D project, Government of India, Ministry of Electronics is supporting IoT Sandbox. It is just a complementing the National Trust Center. National Trust Center is one where the manufacturer or somebody will go and get the certification. IoT Sandbox is the thing where you can actually, you develop something you wanted this to be validated functionally and security aspects. This particular infrastructure will provide. This is being done by multiple organizations, including STQC. So CDAC is the main organization, and even SETS is involved from India, and IITs are also involved in this, IIT Madras and so on. So there is a handbook for security testing and evaluation. I think I repeated probably that. IoT security standards are coming to roll up BIS. ISCA, in its future skills, they are addressing IoT security. Future skills is joint program of Ministry of Electronics, CDAC and NASSCOM. So they are also getting into some of the future skills, specifically in IoT and IIoT. And they are addressing how to train the, CISOs, Chief Information Security Officers who are handling the IoT devices, how to train them. So such novel courses are also being thought of. Industry bodies, many industry bodies, like I already mentioned, BIS, TSDSI, the Telecom Standards Body, and Data Security Council of India, and NASSCOM. There are many organizations who are working towards this. And I'm not going into this. You get into National Trust Center under Telecom Engineering Center, you get details. Basically, they are addressing a framework for National Trust Center for machine to machine and IoT devices applications. And there is a working group, and it's the efforts are right from 2017. TRI is also involved in the original idea. And IoT Sandbox, I will not once again go into. It provides testing environment, an isolation environment, and a monitoring platform. This is basically to help for the pre-qualification certification trials. People can come and do the things. And this particular sandbox contains a lot of tools, different techniques, and different domains, consumer, automotive, etc. And standards. It has to comply because it is certifying, evaluating. It has to comply. It should have the environments and different stakeholders, product OEM, certification bodies, security testing labs, etc., etc. Sorry for the quick run through all this. This is, of course, is a very different thing. A lot of in each level. What are the hardware level security testing? You can see RS485 USB evaluation. That is, if you have a USB interface for IoT, how to evaluate. If you have RS485, how to evaluate. CAN bus, how to evaluate. I2C, how to evaluate. Through firmware, reverse engineering, secure firmware updates, anomaly detections, etc., AML, algorithm fuzzing, so on and so forth. So you can see side channel leakage and cryptography testing, network level security testing like LPWAN, Wi-Fi, Zigbee, whatever name, all these things they have to support. If I come with a device with this particular communication protocol, this firmware, this device hardware, this side channel leakage possibility, this sandbox environment getting created by the MATI with all the stakeholders has to help. These are the lab that they have released a handbook. I'm not going to the details. This handbook gives you complete security testing and evaluation lab, what it should contain, hardware, firmware, wireless, and so on. And it addresses various devices. This is available on the MATI website on roadmap, National IoT Security Roadmap. You can see 2024 to 47. It's I think it goes up to 100 years completion, right? The of independence. You can see the vision is towards IoT device security, IoT network security, IoT application security, IoT cloud platform security, AI-based IoT security, quantum-enabled, lightweight cryptography, semiconductor standards, etc., etc., with a lot of goals. And once again, goals mentioned indigenous security ecosystem, AI-powered, PQC-enabled, no power cryptography algorithm, no power, that is, it should not consume power, security on IoT-enabled digital twins, and so on. Major outcomes, IoT security solutions. I don't go into these things. Beneficiaries are enterprises, consumers, okay, hardware developers, regulated bodies, research community. A lot of references. I've just given a brief list of things. Okay. Thank you. This ends my formal presentation. I just want to end with a quote by Richard Adler, of Distinguished Fellow. I quote, despite continued security problems, the IoT will spread and people will become increasingly dependent on it. The cost of breaches will be viewed like the toll taken by car crashes, which have not persuaded very many people not to drive, unquote. So this is about DSCI. I would probably, Data Security Council of India addresses security and protection. This is my present organization. And if you go into the website, you will get a lot of details on cybersecurity. A lot of white papers will be there of the latest things. They conduct every year annual information security summit. It's brings all industry working in India. So it's going to be thing. Under that, Ministry of Electronics, jointly with DSCI, established the National Center of Excellence, which connects the research outcomes that are happening from academic and research labs to the startup ecosystem. Idea is to, whatever POCs, proof of concepts come, how do you productize, commercialize through the industry? So they try to provide the platforms and try to connect them. And those who become National Center of Excellence members, they get benefited in that direction. We can probably go into the website and get those details as well. So this is just completing my part of the things, but there are a lot of questions which are things. So what is the way, shall I go ahead with the question and answer?
Yeah, I will ask the questions. Sir, thank you so much for delivering the wonderful session.
Yeah.
We have a few questions from the participants.
Yeah.
One is from Amar Ankush. He's a librarian. He asked whether IoT and its application can be used in libraries. How it can be used in libraries?
Yeah. Right from the stock verification, use RFID tags, connect them all. Okay. And also the space utilization and also the lighting of the library. Most of the time, library is suddenly full when the classrooms are open intermission or sometime, and suddenly there will nobody, but lights will be glowing everywhere, wasting energy. So IoT devices like occupancy-based lighting can be used. And as I told you, the books, whichever books are more frequently used, you can analysis based on the data that is available. The analysis could be done, and so these are some ideas that are coming in.
Okay, sir. Thank you, sir. Sir, most of the questions you already addressed, I think. IoT and blockchain
Correct.
related questions also you addressed in the presentation.
True.
And some questions like tools. Please demonstrate the open source tools for IoT.
I have a suggestion. You should organize a half-a-day tutorial. I will bring some experts from CDAC and sets. They can do some tools demonstration. Definitely, it's a very useful thing for the people.
And few questions from current participants. I think Kasturi Rajan sir has asked, could you please throw some light on ISO and IEC 27000 series? I think this question also you addressed.
Yeah, I gave some list of standards that are available, and they are some are published, some are still evolving. So that is the status.
One question is there, how to reach our speaker?
Me? I think my mail, saratcdac@gmail.com.
I have posted that. Okay.
Yeah.
One more question from Kasturi Rajan sir.
Yeah.
In the industrial IoT, what are the key protocols and ISO and IEC standards followed in the process industries, especially in the critical applications of data?
Yeah, I think this is an area where actually already standards are well established because of the critical nature. But I'm sorry, I failed to remember the numbers at this point of time. But there are sufficient standards. I think it starts with ISO 6.2, something like that. So the critical infrastructure standards, it is already published and people are using it. Yeah.
Another question from Dr. Karthiki and you. Sir, is there any specific approach or technique or driver passenger safety on Internet of Vehicles with Industry 4.0?
Yeah, I think the standard that I have mentioned, that the Society of Automotive Engineers are working on that. The onboard diagnostics should have these security features, and the display should be able to give, because for example, the skidding of brakes, some of the dangerous situations that are happening, that could give a warning, a kind of audio warning it can give, because there is enough hardware getting built into these automotive cars, and they are going to give that internal to the car what are all the security things they display. They display and also give an audio signal to the driver, and they also give the driver behavior. That is, if he is sleepy, they will understand from the anomaly of his driving thing. They will warn him with the proper audio alerts. So these are all built into the cars on the roads. This particular standard is addressing the entire life cycle, right from the manufacturer to the car sales to the user. Everyone, including the regulation bodies, everyone is involved in this thing. There is a total cycle of the stakeholders are involved in this ISO SAE standard of 21434 that is meant for the automotive sector.
Okay, there are a few questions from Kasturrajan sir. Due to time constraint, we will consolidate all the questions.
Yeah.
He has asked what is the accuracy level and reliability in threats and mitigation in the IoT. Also, he included how AI, using AI in IoT security. And all. Okay, I think we can answer first to these questions. And
yeah, I think it's a very relevant question. It's a very difficult thing for identifying every possible security breach and thing, because there are so many paths to which attacker can attack, and there are so many devices. Every manufacturer is not addressing unless the security by design strictly done. That won't be limited. Not that security by design totally avoids the possible attacks. Still, there will be certain weaknesses of implementation, or certain level of code bugs will be there, and attacks will still happen. So, in spite of all care. So, as we mentioned rightly, AI has that capability because it can see the minutest changes. It can also see based on its history of earlier attacks. Most of these attacks will follow a similar behavior with minute changes. So when it sees that 95% or 90% of the way is what earlier attack and now 5% thing, it can easily identify. And also it can see what is the traditional right approach, because I have whitelisted, let us say, and whitelisted applicant how it behaves. If there is any change, I am able to identify using the machine learning kind of techniques, and will be able to quickly identify that. So anomaly, basically anomaly detection, close to 100%. So how effectively used? But only thing is, this AI will be also used by, it's a double-edged sword, will also be used by the attacker. He will attack and he will see whether such systems you are using, then how to bypass that he will worry. So this is the kind of a cat and mouse fight.
thank you, sir. And another one more question from Kasturrajan sir, as well as from Vallisami sir.
Yes.
They are asking about whether the courses you listed is offered by CDAC or STUC, whether they are short-term courses, and whether it is offered to students, faculty, and scholars.
No, these are all the possible areas of what people can do, and some are research directions. So some of these courses are being conducted by CDAC. CDAC has a 6 months course on IoT. In that, they have modules on IoT security, not exclusively on IoT security. There is a 6 months course, but there are a lot of workshops are happening. As I told you, Data Security Council of India have recently started. They're already writing white papers and publishing on the thing. They are started IoT security acceleration program, under which they will take different verticals. First, they have launched it by bringing all experts and identifying what needs to be done. Now, time to time, they will announce in each vertical how to take care of IoT security, like automotive security, energy, water, agriculture, and so on and so forth. This is the idea. And in addition to that, NILET also planning to offer courses on IoT security. They are already under ISCA program itself, under education and awareness, they are doing a lot of courses are happening in IoTs and all. I don't have the specific list, but it's happened. That much I can tell.
Thank you, sir. Thank you for sharing the knowledge with us.
Yes.
Now I request Dr. K. Komathy, Chair CSA Chennai chapter.
Yeah, just only one question. I was interested in somebody asked. I think probably it answered, but not effectively. In education, how IoTs can be used? Just only 1 minute I will take. There are a lot of ways IoT can be used. I have seen one novel technique. One of the professor from Kannur University suggested is you use IoT based LEDs of different lightings, and see that with water you do by glowing IoT lights in different directions, you can do the chemical testing. That is, physically you can do the labs without the chemicals. So this is basic idea is you can continue the whatever chemistry experiments that you do using the chemicals, but without chemicals. You can simply use water. That kind of a concept is there. So novel virtual labs, novel remote labs can be done using the Internet of Things devices. That's it. Thank you.
Thank you, sir.
Thank you.
Yeah, thank you, Dr. Godfrey. Good evening, all. On behalf of the organizing units, IEEE CS Madras, CSI Chennai chapter, and ACM Chennai, myself, Dr. Komathy, Chair, CSI Chennai chapter, take this opportunity to propose a word of thanks. To begin with, I thank the chapter jointly organizing this webinar on securing connected world of IoT and IOE, which focused on the significance of data privacy and security in this era of interconnected living. We thank our distinguished speaker, Dr. Sarat Chandra Babu, Advisor, Data Security Council of India, Advisor, Broadband India Forum, and former ED, Society for Electronic Transaction and Security, for enlightening us on the various pilot projects of CDAC carried out in agriculture, water distribution system, etc., using IoT, where devices connected will collect the data, learn, and then take necessary action. And he was touching upon my multi-layer architecture opted with edge computing. Security challenges in IoT devices were discussed in detail, especially Mirai malware that infects smart devices, turning them into remotely controlled bots. To secure smart home IoT devices where a smart speaker could be a smart spy, by which the hackers potentially access users' personal information and even their conversation history. Hacking of cars was cited as an example for relay attack. He advised to disable unused applications or functions for securing smart home. Security challenges in automotive sector and mitigating the risk using defense in depth by utilizing a multi-layer security mechanism were touched upon. The various security frameworks and standards designed for IoT, especially a positive security model with whitelisting, a negative security model with blacklisted devices. Finally, Dr. Sarat mentioned about how AI, blockchain, quantum-enabled cryptography would help us to improve the security. He enumerated some of the national efforts taken in IoT. My heartfelt thanks goes again to Dr. Sarat Chandra Babu, who with his expertise clarified all the questions raised by the participants. I thank the office bearers of the organizing units who supported for the success of this webinar. Our heartfelt thanks to our mentor, Mr. H.R. Mohan, Chair Events, IEEE CS Madras, who presents experts to this platform for the benefit of the members. I'm thankful to the participants who joined us in live Google Meet and YouTube's live streaming as well. And a special mention to those who actively participated in the QA section. I hope this session would inspire many of the participants to explore further on the security of IoT, especially IOE as a research theme. With these warm words, we move to the end of today's event. Thank you all.
Thank you.
Good.
Thank you all from my end also. It's a great opportunity
Thank you
for me.
so much, sir.
I know.
Yeah.
Mohan sir and Dr. Godfrey, everyone
Thank you,
has
sir. Thank you.
taken a lot of interest, and I'm happy to be here and share. I know that there's a lot of learning happens. This is a very advanced area, and we started with the vacuum tubes and now we are here. So every day is a learning thing. And
Sir, I want to request that we will make one tutorial session, sir, especially for the faculty and students. So I will arrange for a tutorial half a day or one day. We will
that
do it.
I earlier mentioned, Mohan sir, also that we need one or two more along with me who will actually work with the tools. That is very important.
Yeah, especially tools, demonstration. That's
Exactly. In one of
So we
the.
will come back to you, sir. Thank you.
Thank you so much, Komathy, madam, and
Thank you.
Mohan sir,
Thank you.
Dr. sir, and all those who are part of this organizing, and all participants for the patient listening. Thank you.
Thank you. Bye, sir.
Thank you, sir.
Thank you, sir. Mohan, sir, thank you so much.
Yes.